We're going to look at exercise 17a, the second example, wherein 6 cards are drawn at random from a pack of 52 playing cards. Each card is replaced and the pack is shuffled before the next card is drawn. And then we need to, that is our situation, and we need to find a variety of probabilities. First of all, we should always be looking to clearly define what our probability distribution is. Here I have denoted that with the x equals, the capital X equals. What the probability of a success is, the P, and therefore the probability of a failure, which is 1 take away P in Q, and also the number of trials. So let's have a look at the situation. We are drawing cards at random from a pack of 52 playing cards. And when we look at the questions we're seeking the answers for, we're looking for 2 being clubs, 1 club, at least 1 is a club, at least 4 are clubs. So the event we're focusing on is drawing a club. So the number of clubs. The probability of getting a club from a deck of cards is 1 out of 4, because there are 4 suits and each of them have the same number of cards. So that's the probability of getting a club. Probability of not getting a club, therefore, is 3/4. The number of cards we are drawing, the question states, is 6 cards. So n equals 6. Now what we can do is to start looking at the particular questions. Question A, it's the probability of 2 clubs. Now, if X stands for the number of clubs, then what we're looking for is the probability that that X is equal to 2 clubs. Now, to work that out, we know we have 6 cards being drawn. So from 6 cards, we want 2 of those to be a club. Now the probability of a club is P, and we're going to have 2 clubs. And therefore we're going to have 4 that are not clubs. So that's Q to the power of 4. And the rest of the work is really just a matter of working out what each of these is equal to. So 6C2, P was 1/4 squared, Q was 3/4 squared. And when we calculate that, we will end up with the answer, which is 1,215 over 4 to the power of 6. Part B is 1 club, and so the probability that X, the number of clubs, is equal to 1 is what we're looking for. Very similar to this. Now they're always similar when it's just an equals. So we're choosing from 6. We're going to have 1 club. P stands for the probability of clubs. So it's P to the 1, so there is 1 club. There are therefore 5 cards that are not clubs. So I have 6C1, 1/4 to the 1, 3/4 to the 5. And that turns out to be 1,458 over 4 to the 6. The next part of the question deals with the probability that we have at least 1 club. So if I want at at least one club, the x being the number of clubs, at least one means has to be greater than or equal to 1. Now, given that we are choosing 6 cards, that means that we're including 1 club, 2 clubs, 3 clubs, 4 clubs, 5 clubs, and 6 clubs. We could therefore do it exactly the same way as we've done question parts A and B by working out the probability of 1 club and of 2 clubs and of 3 clubs and adding them all together. For this is a situation where we've got a whole pile of different cases. But if you look at this list, there is something missing. The number that is missing is 0. So what we could do, instead of working out all of these probabilities and adding them together, we could simply work out the probability of getting no clubs and taking that away from 1. For the entire probability distribution should add up to 1. So we're going to do this instead. 1, take away the probability that x equals 0. Now the probability that x equals 0 is done the same way as we've done A and B. If x equals 0, we have 6 clubs. We are using 0 of them. P is the number of clubs. We've got 1/4. Let's go back again. P is the number of clubs, and so therefore we've got P to the 0. Q is the number of non-clubs, and there are 6 of them. So that's our probability of getting no clubs. We're going to take that away from 1. So we've got 1 take away 6 C0. 1/4 to the power of 0 is just 1. I will write it in anyway so that we see how it's working. 3/4 is Q. That's to the power of 6. When we work that out, we end up with an answer of 3,367 over 4 to the 6. So we've considered all the different options and realised that there's only one missing. So it's best to use complementary events. Part D looks at the probability that we have at least 4 clubs. So if x stands for the number of clubs and we want at least 4, then we need to be looking for greater than or equal to 4. Now if we think again of all our options, we've got 4 clubs, 5 clubs, 6 clubs. The ones that are missing are 0, 1, 2, 3 clubs. Well, that's 4 different things to work out. Okay, so we can just add on these 3 together. So we will work out the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6. And these are done again the same way as we've done question A, B, and part of C. So 4 clubs, we're choosing 6 of those 4 are clubs. P is the number of clubs, or the probability of a club, and we're getting 4 of those. Q is not getting a club, there are 2 remaining. 5 clubs from 6. P to the 5 clubs, 5 clubs. Only the one that is not a club. And finally, 6, C, 6, all clubs. P to the 6, Q to the 0. Substituting in the 1/4 and so on, and the 3/4 for that. Calculating it will finally give us an answer of 154 over 4 to the 6. Final comments. Start by finding x, determining what x is equal to, working out the value for the probability of a success, of a failure, and how many events we are dealing with.